Okay, so what we have here is some data on impulsivity, distress tolerance, alcohol use, and alcohol problems. The, um, the basic hypothesis here is that um, impulsivity uh, is moderated by distress tolerance. And when we're talking about moderated by, what we're really focused on here is the fact that there is some relationship between an independent variable and a dependent variable. And there is an average sort of relationship, but that relationship changes based on your level of some other type of variable. And so this other type of variable can be anything, right? But in this case, we're going to look at impulsivity and distress tolerance. But let's say, just to describe this, like a typical moderation is to say that the relationship between, for example, drinking, the amount that you drink, and the number of problems you have is different for men and women, right? That is a moderation relationship. We're talking about this association. What we're used to thinking about is the amount that people drink differs between men and women, or the amount of impulsivity differs between men and women, but we're not saying that here. Instead, what we're really saying is the correlation between drinking and problems is different, right? Not the mean level, but the relationship. And it can be, it sometimes can be hard to wrap your mind around it. But what I like, the way that I like to think about this is that there is a given relationship between x and y. And we have another value m. And m is a volume knob. And as m gets turned up, then the relationship between x and y gets louder, right? And as m gets turned down, the relationship gets quieter. And sometimes it flips, right? And so what we're always talking about is the relationship between two variables and how that relationship changes based on a third variable, right? This is different from mediation, which we'll get to later on, in which we're saying that there's a relationship between two variables and it's because of a different variable, right? The way that I like to think of mediation is we have two rooms and there's a relationship between these two rooms, and that relationship is that they share a door. And if you open that door, you can walk through to one of these other rooms, right? That's mediation. It's the door that leads from one room to another room. Moderation is different. Moderation is there is a light in the room, right? And that's controlled by a switch that you can make brighter or softer. And so mediation is a door, moderation is a knob. We deal with moderation in the exact same way that we deal with curvilinear effects. And we're going to both test for moderation and we're going to graph it. Now, in moderation, in linear moderation analysis, interactions, we are not expecting our variables to be curved, right? We are going to multiply variables, don't get me wrong here, but there's no expectation that they're going to be curved. Remember, that's all curvilinear is multiplying variables, but it's multiplying the same variable times itself, right? Here, we're not multiplying the same variable times itself, so nothing is squared. We maintain that nice linear relationship. All right, so assuming that we are going to do the exact same steps that we followed to test for curvilinear relationships, if we want to test for moderation, if we want to run any type of regression analysis, what's the first thing that we do? Center our variables. I just showed you a new way to center our variables. If we know that alcohol problems, AP tote here is our dependent variable, what do we want to center? Distress tolerance, impulsivity, and let's center drinking too. So, what do we do to do this? What's our first step? Somebody help me out. Walk me through. Okay, so we go data, aggregate, and let's just start with impulsivity. There we go. Distress tolerance. Oh, by the way, in aggregate, you can just throw all of these in at the same time, right? Drinks, right there. And we hit OK. And if we flip over to our data set, we now have these mean levels of our variables. Now, if we're planning on adding age and sex in there, we should also add those in as at least centering those, right? Should we center both of those? Does not really make sense to center sex. It makes sense in a mathematical sense because if we don't center sex, what's going to happen? What's going to happen to our model? Will anything odd occur? We won't actually get a true intercept, right? We won't actually get the true mean of whatever our thing is because in our regression equation, remember that the reason that we center is that we can cancel out things, and that includes demographic variables. It means that we can remove them and know that because they're multiplied times 0 in a regression model, right, in a straight linear algebra equation. But if the actual mean of sex here is not 0, then we have to account for that fact in our model. Let's try this. Let's go data, aggregate. Let's remove these. Let's center sex, and then let's not center sex. And also age. Just to kind of highlight this point that I'm trying to make. All right, so we've got everything centered here. What's our next step? Say that again. Multiply the two variables that we want to examine, right? So let's do that. What's that? Thank you. Okay, so let's center our variables. Transform compute. And we're going to, let's call this C underscore impulsivity is impulsivity minus mean impulsivity, right? Hit go. Transform compute C distress tol is distress tolerance minus mean distress tolerance, right? Go. Transform compute C drinks is drinks minus mean drinks. Hit go. Transform compute C age is age minus our mean age, and transform compute. And I'm going to do this, and I will tell you that I really don't like ever doing something like this, but sex minus mean sex. Okay. Now all of our variables have been centered. We have all of these centered variables. What's our next step? Jigs. Now we can multiply them. All right, transform compute, and we are going to do C imp by C distol. And impulsivity times distress tolerance. All right. It is formed. We are good to go. Everybody caught up? We all tracking? What's our next step?
Are we multiplying more?
No, we're just interested in this one interaction. We'll pretend like that's the deal today. By the way, if you look on the on web courses, I posted an article about looking at interactions, and I also posted a couple of different graphs that you can use so that you don't have to build them yourselves, though building graphs yourselves is the best way to understand interactions and regression. So, all right, what do we do? What's our next step? Run the regression. Let's do that. Let's go analyze regression. Is everybody caught up? Before I do this, everybody have your variables centered? Everybody form our single interaction. We only have one interaction, right? We good to go there? All right, cool. We said our dependent variable is what? Alc-probs. Now let's do this. Let's control for the amount that a person drinks. Let's throw that in. That's step one. And you know what? Let's control for age, and let's control for sex real quick here. I want to highlight something. So let's do this. Run that model. Here are our slopes of our control variables. And what you can see is that sex-centered has a significant effect, right? Age has no effect on alcohol problems. Drinks, the more you drink, the more alcohol problems you have. That makes sense. How do we interpret sex right here? The only way to interpret it is to understand what the mean of sex is, and we can't understand that mean here, right? But this number, 0.972, is the true mean of alcohol problems. If instead we go analyze regression, linear, and we don't use the centered sex variable, we use the regular sex variable, what is going to change in our model? Will the slope of alcohol change? Nope, you're right. Will the slope of age change? Nope. Will the slope of sex change? Nope. What does change? Just the intercept, right? So we scroll up a little bit here, and here's what we had before. 0.972, 0.827, minus 0.012, and minus 0.2. And as we scroll down here, we see 0.827, 0.012, minus 0.20. Those are all the same, right? But this changed, and it changed by what? Did it change by this amount right here? Minus 0.20? Okay, so we were at 1.051, and it's 0.972. So 1.051 and 0.972 is how much? It's about 0.08, right? So obviously it's not this. What could it be? This is all based on a simple linear algebra equation, right? It has to be, these get canceled out of the equation because their means are 0, right? It's a slope times 0 plus a slope times 0 plus a slope times whatever the mean is of sex. So let's go real quick. Analyze descriptives, explore sex, throw it over here. Okay. 0.40. And if we grab our handy little calculator and we go 0.4 times minus 0.2, oops, 0.4 times. Oh, it's 0.08. That's the exact amount that slope change, that intercept changed by, right? So the intercept is, this is just a way to highlight, like, when something is not centered, that's going to affect your intercept by that slope times the mean. When you center everything, it won't affect your intercept because in a regression equation, that gets canceled out. It's still your slope times your mean, but when it's centered, your mean is 0, so you're adding 0 to the intercept. It doesn't matter, right? Yeah, all right. Let's go back to our analysis then that we had done here. Analyze, regression, linear. Let's for just the time being, let's leave centered sex in. So we're controlling for sex, and it doesn't change anything. The R squared doesn't change, nothing changes. It's just, it's harder to interpret, right? When sex is centered. But anyway, this will give us a true intercept at least. We're gonna go next step. What are we gonna put in the next step? We have a hypothesis here, and that is that there's an interaction between distress tolerance and impulsivity, right? Impulsivity? Anything else? You could put distress tolerance if you wanted, or you could slide it into the next step. It's completely up to you. We'll throw it in the next step just for the hell of it. And last block. The interaction of these two, right? Statistics, we're going to want to get an R squared change. We're going to want to get our collinearity diagnostics to make sure that our centering was effective. Don't need that. I think that's enough. We ready? Did you see what happens? In full disclosure, I ran this without drinking in. I'm not positive this interaction will work. We'll see. All right, so looks like it worked though, right here. We see that the initial R squared is 0.492. That was accounting for drinking, age, and sex, right? We'll get down there in a second. We see an increase of R squared of 0.031 when we added impulsivity. And that's a significant increase. We next added distress tolerance, increase of variance accounted for of 0.013. It's not very much, but it's also, again, a statistically significant increase. And then finally, we see an increase in variance accounted for of 0.02. And again, not much, but it's going to be a statistically significant increase. By the way, this p-value right here should be, I hope I'm not wrong here, the exact same p-value that we see for our interaction effect, right? So we have a simple linear model. We come down. Who wants to say step one of this model? What did we do? In step one, okay, I would start by saying we regressed, right? Or you could say we controlled for alcohol use, age, and sex by regressing alcohol problems onto these three variables, right? If that's how you wanted to phrase it. You could say this accounted for 40% of the variance, whatever it was, I don't remember, right? What else would you say here? What else might you say?
So drinking itself has a positive effect on alcohol problems.
Yep. And you could list the p-value. I wouldn't list the slope. Also, sex is inversely associated with alcohol problems. You could list the p-value, right? Just as a point of note here, sex is a categorical variable, 0 and 1, which means you can use this difference of minus 0.20 to say that there is a 0.20 difference between men and women in alcohol-related consequences. And that means you can also do what? That's a difference in means, right? You can grab the overall standard deviation of alcohol problems and calculate Cohen's d and say, here's the magnitude of effective difference between men and women, right? Okay. And you might say age was not associated with alcohol problems. In step 2, impulsivity was added to the model. This resulted in a significant increase in variance accounted for. And you could put change in R squared, blah, 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 right? And impulsivity was positively associated with alcohol problems. In step 3, distress tolerance was added to the model. Distress tolerance was inversely associated with alcohol-related problems. And we had a significant change in variance accounted for in the model. And you could put your R squared. And you don't have to say anything about this, but just FYI, distress tolerance and impulsivity are positively correlated. Do we see any concerns with our collinearity diagnostics right here? Nope, those look fine, right? In step 4, the interaction between impulsivity and distress tolerance was added to the model. This resulted in a significant increase in variance accounted for, though it was meager. And you would list this slope and this p-value for your interaction, right? Note that again, these collinearity diagnostics look good. If you didn't center these and you formed that interaction, they'd look bad, right? You would get the same sort of thing that you wind up getting with cubic and quadratic effects in a model. And though those things would look bad, the magnitude of p-values would not change, though these things over here could change. Those slopes could change, right? At least the intercepts would change, for sure. All right. What do we conclude from this? Let's say that our interest is in the relationship between distress tolerance and alcohol problems. So what we really want to know is, does higher levels of distress tolerance result in lower levels of alcohol problems? It does. What else do we get from this? Mm-hmm.
Higher level of impulsivity, might be the negative effect of the stress tolerance becomes weaker on alcohol.
Weaker, is that what you said? Yeah. Yes, that's correct. Although it's kind of tough to figure all of, I mean, to have to sit here and say like, okay, so this slope is going this way and this one is going this way, and then there's an interaction that is negative. But what that interaction actually means, because it's negative and the moderator is positive, that it's going to pull distress tolerance up. The magnitude of effective distress tolerance will go closer to 0 as impulsivity gets higher. There's an easier way, right? And the easier way is to say, we have a basic regression equation right now, right? We have a regression equation that is y equals intercept plus b1 times xm, the mean, plus b2 times x1m, x2m, plus b3, which is x1m times x2m, right? And the way that we look at this is we say, well, what we're really interested in is this. We really want to know what is going on with this slope. Because remember, we're talking about the relationship between just the dependent variable and one independent variable. That's what we care about, right? And what we're saying is that that relationship, the correlation between these two things, changes depending on the level of this third variable. And this piece over here is what tells us that that happens. The easiest way to figure this out is to say, all right, we're going to set this variable at a different level. We're going to force it to be different. Right now, we're multiplying this in this model times what? times the mean. And our mean of x2 is what? It's 0. The way that we can test how this changes is by saying we're going to fix this to be some other value. The most common value that we use is a simple standard deviation. So let's do that. Let's find out what our standard deviation is of m. So let's go analyze, descriptives, explore, remove that, and let's put both impulsivity and distress tolerance over here in our dependent list and hit OK. Now before we go any further, we have to decide which one of these is our x variable and which one is our m variable. Which one should be our x variable? I mean, I was saying distress tolerance, we might as well stick with it, right? So that means impulsivity is going to be our volume knob, and the standard deviation of impulsivity is what? 0.78929. We're just going to call this 0.79. Doesn't have to be, this is less important that it's precise relative to the mean. In truth, you can pick any value here that you want. You could pick quartiles. You could say we're going to go with the 25th 25th percentile, sorry. You could say we're going to use one standard deviation. There might be something that actually has some meaning. For example, in clinical psychology, we often have like in an assessment, for example, if we're using the MMPI, we might have a scale that crosses what we think of as a clinically significant threshold of 70 or 75. Is it 75 or 70 in the MMPI? Somebody help me out. 70, right? Yeah. And so we might say we're gonna set that scale to be a value of 70 for everyone, right? And then we're gonna go from we're gonna look at this based on that level. So here we're gonna use 0.79, and we're gonna come back and set everybody's value to be one standard deviation. We're gonna set their mean to be one standard deviation above, which means the true mean is one standard deviation below where we set it, right? How do we do that? We have to form a new variable, so let's... Perfect, that's exactly what we do. Transform compute, and we're dealing with impulsivity. So we want to do C impulsivity plus 0.79. That's going to set our new mean to what? 0.79 above whatever. So if somebody, our new actual mean of that variable will be 0.79 because our mean right now is 0. So if we set the new mean to 0.79, that means our true mean is 0.79 less than what it should be, right? What we're actually doing here is setting our mean to be one standard deviation below where it is. By adding 0.79, you're setting your mean at a standard deviation below. This is a frustrating issue because that also means when you subtract a standard deviation, you're setting your new mean to be one standard deviation above. And it seems odd to add a standard deviation and say it's now set one standard deviation below, or to subtract a standard deviation and now say it's set to one standard deviation above. But the rationale is that you're not worried about where you're setting your new mean. You're worried about where your old mean is relative to that new mean, right? And so by adding, you set your standard, you're at one standard deviation below. By subtracting, you're at one standard deviation above. Who's lost? Oh.
A little bit.
A little bit? All right. You're going to have to trust me. I say this every year. You're just going to have to trust me that this is correct. And I'll prove it to you here in just a second. So let's go. If I have this equation in there right here.
So
yes.
does it matter if I set it
above or beyond by 1 standard deviation?
No, because we're going to do both.
Okay.
We have to do both in order for this to work. You don't have to, I guess. Maybe you just want to look at one side of this. So this is going to be, we're going to create a new variable called low impulsivity. And that is impulsivity at plus 1.79. And hit OK. And then transform compute. And we are going to have high impulsivity. And to get high impulsivity, you subtract 1.79 from the mean, right? And I know it seems counterintuitive.
But
Okay.
always have in mind then that you're referencing the old one. That'll kind of
Yes, that's the way that you have to keep that in mind is when you are adding or when you are subtracting, what you're really doing is referencing that to the old mean, to the true mean. And I say true in quotes because it's not really the true mean either, because we've already subtracted the true mean from each individual observation to make the mean 0. We've already centered it, right? But anyway, okay. So now, if we look at our data, we have low impulsivity created and high impulsivity created, right? And what this is really doing is saying this person's, average impulsivity is 0, and I'm going to change it so that their average impulsivity would be 1 standard deviation above where it normally would be, or will be 1 standard deviation below where it normally would be. And we have to remake our interactions. So we're going to go transform compute, and we're going to say dist by high impulsivity equals centered distress tolerance, we don't want to change that, times our high impulsivity. Hit OK, and transform compute dist low impulsivity is distol times low impulsivity. All right, so we have made all new interactions. We have set our variables to high and low levels. And now,
Can you hang fire? We're catching up.
yeah.
say that again?
Can you hang fire? We're a bit lost over
Okay.
here. At least some of us are.
Sure.
So we've got,
Where are you at?
so I'm trying to put in the first equation that you just went through.
Okay, so have you made the high and low levels of
Yes,
impulsivity?
I'm up to there. I just
Okay.
missed these last two.
I just made an interaction, which
Yeah.
was distress tolerance, the centered distress tolerance, right? Times the high impulsivity that you made,
Okay.
and hit OK. And rename it, like distress tolerance times high impulsivity or something.
Okay, now I do the same for that.
And do the same for low, yep.
Okay.
Because what we're going to do here is we're going to run 2 new regression equations, and we're going to say, what is the relationship between x and y when impulsivity is high, and what is the relationship between x and y when impulsivity is low? All of these things that we're doing are strict linear transformations, which means for the most part, absolutely nothing should change in these models. Intercepts shouldn't change. The effect of our impulsivity slope should not change, right? It's just moving it around. The effect of our interaction should not change. The p-value for the interaction should not change. The only thing that should change in these models is the relationship between x and y, because we're saying that that interaction changes that relationship, right? So, everybody have our new interaction variables calculated? Let's go analyze regression linear. And we're going to have to move back a few steps. So we have impulsivity right here in block 2. You know what? Let's take everything out of all of these blocks. Block 4, block 3, block 2. We can leave the stuff in block 1, actually. In block 2, I thought I removed that. Okay. In block 2, let's add our centered distress tolerance. That's fine. Sure. So block 1 should be drinks, age, sex, all centered. We got there? Block 2, let's add centered distress tolerance, and let's add, should we look at low impulsivity first or high impulsivity first? Low. Thank you, David. We will just throw low impulsivity in there. It's not centered anymore, right? Because what we're saying is we're going to set impulsivity for every single person to be 1 standard deviation below where it actually should be. Let's remove distress tolerance here. And for this last thing, let's just throw in distress tolerance by low impulsivity. Let's go to step 4 and let's just delete that out of there. So we don't even have 4 blocks anymore, right? So you guys should look like this in step 1, drinks, age, and sex. In step 2, distress tolerance and low impulsivity. And in step 3, distress tolerance by low impulsivity. We good to go? Hit go. And our variance explained should remain exactly the same. And it is exactly the same, though remember I put 2 things in step 2 now instead of doing step 2 and step 3. Our p-value of our interaction was what before? 0.023, right? It doesn't change. Our slope of our interaction says minus 0.077. Let's scroll up here to our last interaction. That's weird. Why? Oh, there it is. I'm sorry. I was looking at something else. There it is, minus 0.077. P-value is the same. Our slope of impulsivity right there, 1.29, right? And our slope of distress tolerance, minus 0.178. One of those should change, one of those should not. Which one should change? Distress tolerance, right? We're saying that distress tolerance changes as a function of changing impulsivity. So somebody remember impulsivity is 129. Somebody remember distress tolerance is minus 178. Scroll back down here. Impulsivity, even at low levels, 0.129. That's because it's a linear effect. It's not going to change at all. Distress tolerance, did that change? Yeah, at low levels of impulsivity, distress tolerance is now 0.117. What was it before? It was 0.78? 0.178? Okay. So 0.178, I'm going to... Gotcha, yeah. All right. What can we conclude from this? Let's run the next model, and then let's see if we can come up with some conclusions based on that. So let's go regression linear. We have to remove low impulsivity. We have to add in high impulsivity here, right? And if we go back, we have to remove low impulsivity from step 2 and add in high impulsivity at step 2. Are we ready? Who's with me so far? Step 3 is we're adding the interaction with high impulsivity. All right, you hit go. And should our slope for our impulsivity change or our interaction? No. Something very interesting is going on though, right? I wonder if I screwed this up as I was doing it, because I feel like I must have screwed something up. It looks like the relationship between distress tolerance and alcohol problems is stronger, more negative, for people with high impulsivity, right? Is that right? So either one of 2 things happened. Either I screwed up when I was making these variables, or people with high impulsivity, distress tolerance is just more important for them, right? And that's maybe what we can conclude here. If you have high levels of impulsivity, the relationship between distress tolerance and alcohol problems is stronger. If you have low impulsivity, it's not as strong. And that probably means that it has something to do with the relationship between impulsivity and alcohol problems. The problem is really hard to wrap your mind around what's going on here if all you're looking at are these numbers. You've got this weird kind of thing that kind of seems contradictory to what you might expect, right? How can we break this down into a way that would be more understandable? How can we really understand what's going on here? Graph that stuff, right? So let's take a 10-minute break, and when we come back, we are going to graph out these slopes and have a look at it so we can figure out what's going on.